according to Cloud. Whatever, let's do this. So forget trig. If I just said in this lesson, solve equations, try to think back to past lessons. What does that mean? Solve this polynomial. Yep.
Find the value of x.
That makes that true. Exactly. That's it. The difference between polynomial equations where you have to factor and you know do factor theorem, remainder theorem, right? Rational zero, whatever, turn it into brackets or binomials, figure out what makes it a zero and blah blah blah. And trig functions or trig equations is one concept. Cast rule. So what makes this x value true? Well, you try to get that all alone and then put it into the equation and solve for x. But when you solve it, you'll realize, oh, sine is a positive 1. Well, there's one more answer. But what if sine is a 1 over 2? Well, there's 2 locations on a circle that can equal 1 over 2. Cast rule. That's what we need to remember. There's more than one, almost always there's going to be more than one answer. But let's take a look at this one as an easier introduction, and then we'll start adding things together. And if you start adding more stuff onto it as layers, maybe there's more room for factoring for something like this too, right? Do you remember doing factoring for trig? No? Never mind. Maybe we'll get to it. Maybe in grade 11 you'll remember. Example 1. So here is my, before example 1, here is my little reminder. If I say the equation of sine theta is equal to 1, we have multiple answers. And on top of that, also, we have to consider cast rule for other angles that are not 90-degree multiples. So all of the questions are often going to give you a certain domain. If it doesn't give you a certain domain or interval, then you have to say all the angles that are coterminal with this one also fit the bill. I'm going to give you an example of that, okay? Example 1. Solve 2 sine x plus 1 equals a 0. Well, that's great. Normally, setting it to equal 0 is a good step because we'll then be able to factor blah, blah, blah. For sinusoidal functions, for trig functions, we actually need to isolate. So I'll do step by step. That's a -1. That means sine x equals 1 over 2, -1 over 2. And you can solve that. So what is x? So this is the algebraic portion. Next is the trig portion. Go ahead, Quinn.
7 pi over 6, 11 pi over 6.
7 pi over 6. Yes, that's true. Can you go through the next thought process? Once you see this, what did you think?
When sine x is like -1 over 2, first of all, it means it's negative, so it's in third or fourth quadrant.
Good.
It's -1 over 2, which means that it's like the angle is pi over 6.
Right. So there's a couple of things we need to think about. Number 1, you look at the sign. Oh, it's in quadrant 3 or quadrant 4. What angle gives me 1 over 2 in quadrant 3 and 1 over 2 in quadrant 4? Well, let me try it. We have quadrant 3, quadrant 4. And again, if you can do this in your head, amazing, right? But if not, then take a step forward by drawing and see if you get used to it. What angle gives me opposite of -1 with a hypotenuse or radius of 2? What angle gives me opposite -1 hypotenuse 2? That should look like a special triangle. Okay. Another way you could look at it is, what angle in the first quadrant, in other words, what related angle gives me a positive 1 over 2? You can do either approach. So, what angle gives you 1 over 2? And this part, let me put a little reminder. We're pretending if it's in quadrant 1, we would get positive 1 over 2. Yep. Yeah. Thank you for giving to me in radians too. I appreciate that. Okay, pi over 6 is my quadrant 1. But since...
Mr. Cini, please make your way to room 305 for your on-call. Mr. Cini, please go to room 305 for your on-call. Thank you.
Even teachers are getting sick now with the wave. Who here has siblings that are getting sick or friends that are getting sick? Apparently it's a big wave right now. Yeah. Lucky, quote unquote, lucky for me. My kids all got sick in October. So we're good now. So quadrant 1, pi over 6. That means in quadrant 3, my angle must be my pi plus that. And in quadrant 4, the angle must be 360 or 2 pi minus the related angle. Following this, pi plus pi over 6, it's going to be 7 pi over 6. 2 pi minus pi over 6, it will be 11 pi over 6. There are 2 answers that make this true. And I am done because this tells me it's in just 0 to 2 pi. I have covered 0 to 2 pi. Which begs the question, Mr. Kidd, what if this wasn't there? What if this wasn't there? Then you have to say, well, it could be 7 pi over 6. It could also be 7 pi over 6 plus a full rotation, because that's coterminal. It could be 7 pi over 6 plus 2 rotations, because that's coterminal, so on and so forth. If there was no domain, just put a little star. If no domain, your answer would be quadrant 3 is, the angle is 7 pi over 6 plus multiples of a full rotation. And of course, comma, n belongs to integers. In quadrant 4, same thing. Theta would be 11 pi over 6 plus multiples of a full rotation. In this case, it's 2 pi, where n belongs to that. So another way you could do that is you don't have to write NEZ twice. Just write, just make both declarations and just say NEZ just once. It's fine because it makes sense. Yes?
So what's the final answer?
For this question specifically, because the domain was given, these 2 are the answers. If I plug in 7 pi over 6 into sine, then multiply it by 2, then add 1, I will get a 0. The same for 11 pi over 6. So should I put a little thing? Therefore, if x equals 7 pi over 6 or 11 pi over 6, 2 sine x plus 1 equals 0. Either answers work. That's all it means. This question gives, it's a very sort of introductory, this is the heart of solving trig functions. I give you some trigonometric function, it equals a number, we figure out what angle makes that true. But because of CAST rule, oftentimes you'll have 2 or possibly more answers to it. What makes this more complicated than we have now? The question I give you, I can start manipulating. I could give you, let's say, sine squared plus sine plus something. I can make it look like a polynomial. And you have to do regular factoring. Ugh. I could turn this into maybe like a trig identity, and you have to simplify it, and then you have to, solve for x or something like that. I could turn it into a rational, something divided by something, and you simplify it and you have to solve it. So the scope of the question can exponentially get difficult, but all the skills that we have been learning so far will start coming in handy. So it's up to us to experience, to go through, to expose ourselves to all the different ones so that nothing catches us off guard. Essentially, what I'm saying is, from today until next week, we're studying for the test. We're studying towards the test. That's just different types of examples. Let's try different questions, see what kind of things you might see sometime in the future. Not maybe on the test, but other places. Just exposure, just constant exposure. Okay? So again, I'm not going to try to stress you out. I do want you to have some time for your assignment too. So let's do some of the more simpler things just so that you understand, like, oh, this is what we're trying to do. This is the general idea of what we're trying to do, and then put that aside for tomorrow. Question, Melina?
Well, if 2 pi wasn't included, the answer would be the same.
If 2 pi wasn't included, what do you mean?
I mean, it was 0 until 2 pi.
That's right. If the question didn't give you this, you don't know which answer is true. You don't know if it's this one or 2 circles and then like 2 circles here and then this one. They're all coterminal and they all work, which also makes sense because you know that trig functions, it repeats, right? And so you don't know which one it is. Actually, shameless plug, can I do that for you, everyone? Let's pretend my angle is what I'm trying to do is make sine equal a -1/2, okay? The question said, what is the angle that makes a sine a -1/2? Based on our question, that's right here, 7 pi over 6. I also get -1/2 right here, which is 11 pi over 6. But that's not all. If I continue this curve, I get a -1/2 right here and a -1/2 right here. This is why I mean 7 pi over 6 plus another 2 pi, 11 pi over 6 plus another 2 pi are valid answers. What's worse? I can go this way too. This angle, which is 11 pi over 6 minus 2 pi, or that angle, which is 7 pi over 6 minus 2 pi, they are also valid answers because they give you -1/2. So which one am I talking about? Either I'm talking about all of them, or the question will give you a specific domain to deal with. Okay? So let's just hope that I give you reasonable domains, which I usually will. But when we practice, we should be able to go through some interesting ones. All right? Any questions before we attempt the next one? No? Then while some people are copying this, I would ask that you go to page 2, see if you can isolate your trig ratio, the trig function. Get it all alone. Yep.
This just proves the coterminal.
Pardon?
This just proves the coterminal.
One second. I think I might have to. All right. All right. Tangent. Once again, there's a couple of ways you can approach this. My general gut reaction is to use cast rule to make sense of the situation. I think about what that would be, what this angle would be if the value was positive. In other words, I always go back to quadrant 1. You may not. I'm not saying you're wrong, and I'm not saying I'm right, and you have to follow my way. Whatever method you choose, you have to understand. I'm going to try to show you both once again. If you have a different, more creative way to do it, then go for it. For me, I would say if this was in quadrant 1, then wouldn't my tangent be a positive, right? What angle gives me a positive 1 over 3? 1, 3. That means 1, 3, root, wait, 1, 2, root 3, 1, 3. Whoa, I'm tripping up here. Did I make a mistake? Is there an angle that gives you 1 over 3? No, it's always root 3, isn't it?
Yeah.
Okay, so let's pretend I made a mistake, and using your calculator, this was one of those situations where we're gonna have a rating. Okay, let's roll with it. Let's pretend I made a mistake on the thing, but I'm like, yeah, you can still do it. Use your calculator. If I do inverse tangent of 1 over 3, what's my radian? Am I in radian mode? Yes, it is. I get 0.322 radians. I know that sounds silly, but just know that is in quadrant 1. And it's quite the small one compared to half, because remember, pi over 2 is approximately 1.57 radians, right? And that's 0 radians. Because tangent is in quadrant, sorry, let's back it up. Because tangent is in quadrant CAST 2 or in quadrant CAST 4, since tangent x is negative, what is my angle? If you forgot or you need a refresher, that the angle that we are in question is equal to pi minus the related. And for quadrant 4, the angle that we're dealing with is 2 pi minus the related. I'm going to say x, angle that I'm looking for, is pi minus 0.322 radians. And my x is 2 pi minus 0.322. So what is it? We've got pi, let's use exact values, minus 0.322. The angle would be 2.82 approximately. The angle here, 2 times pi minus 0.322. That is approximately, let's use approximately, 5.96 radians. Okay, and that makes sense. Remember, a full 180 degrees or a pi radian is equal to 3.14 radians. So a 2.8 is not in quadrant 3. It's definitely before 3.14. Pi, 0 radians, a coterminal with 2 pi, which is equal to 6.28 radians. 5.96 radians is smaller than 6.28, so I know it's going to be in quadrant 4. So it all sort of works together. It makes sense still. The numbers work out. Am I done? Almost. So this would be the end. End? Don't write end. I'm going to erase it. Okay. Is that the end? The domain that we covered is right now from 0 to 2 pi. I need the negative side. One cycle on the negative side. Is there an easy way to go through it? I don't want to do any more cast rule. How about we just do coterminals? Okay. So this, let me erase the end. Okay. So this is for 0 to 2 pi. For negative 2 pi to 0, here's what I'm going to do. X is going to be approximately 2.82, but go left or subtract 2 pi. The other angle is going to be approximately 5.96, go left or subtract by 2 pi. The angle in the previous cycle is going to be 2.82 minus, let's just be rough here, 6.28. That's going to be approximately negative 3.46 radians. And 5.96 minus 6.28 is going to be negative 0.32 radians. So there it is. So what answers this question in that large domain? So therefore, X is going to be negative 3.46, negative 0.32, 2.82, and 5.96. Each of these have a coterminal pair, and they fall under the domains from negative 2 pi to positive 2 pi. Yes?
What's the point of that very first step in quarter 1?
This one?
Yeah.
This section gets me to identify my acute related, which helped me find quadrant 2 and quadrant 4 very quickly. I use it to subtract from pi and 2 pi. If you remember, this right here is a full pi minus the acute related. And same with that one. Let me see if I could draw a mini. That's 2 pi minus this little piece.
So why did you solve for it in quarter 1?
Pardon?
Isn't it negative in quarter 1? Does that matter?
No, if it's in quadrant 1, tan x would be a positive, right? So I use that to figure out what angle am I dealing with. And if I know this angle is 0.32, I know that that angle, this angle, this angle, they would all also be 0.32. Acute related angle is very useful to calculate the related angles in all other quadrants. So casserole. So chew on it. Come see me if you have further questions. Again, it's a little more extra work because there was an extra piece of the cycle that we added on, but the essence of it is the same. We take a look at what x could be, and then we fit it into the correct quadrant. We figure out what x could be, fit it into the correct quadrant. Okay. Example 3, write a general solution for the trig equation 2 sine cos equals cos 2 theta. Okay. Do I want to do, you know what? Yeah, let's leave example 4, 5, 6 for another day so that we have some time for the assignment. So as I said before, sometimes it gets hard because I force factoring and stuff. We'll leave that for tomorrow, okay? This will be my last example for today. Write a general solution for the trig equation 2 sine theta cos theta equals cos 2 theta. Now, embarrassingly, I forget what the spirit in which I assigned this question was for. Where did I leave my answer? Give me a second. Pause that video for a second. Okay, you know what? Let's take a look. I have it somewhere. What did I want to do with this? Oh, that's where I want you to. Okay, so we've actually done this already. The concept that I wanted to introduce in example 3, I think I already did here. The idea that if there was no domain, you have to consider all coterminal angles. Let's solve for this. Write a general solution for this to be true. When is this equal to that? Now, I don't want you to go into, what is it? Theta. I don't, that's not the goal here. I am looking for answers that make this true. For what angles is this left side equal to that right side? That's hard, right? So we're gonna get a little bit more creative. Anyone recognize 2 sine cos? Yeah, that's right. So I am going to turn this into sine 2 theta equals cos 2 theta. Remember, this is not an identity. This is not an identity. What I'm going to do is manipulate it and say 2 sin theta over cos theta equals 1. So yeah, because I'm dividing both sides by cos theta, which means tangent of 2 theta equals 1. Yep. From here to here?
No, from
there to there. Yeah. I'm just trying to manipulate. I've divided both sides by cos. So this becomes 1, and that becomes tangent. Okay? Now, from here, so let's take this to the side. Tangent of 2 theta equals 1. What does that tell you about 2 theta? 2 different angles, yes. Since so same as before, since it's positive, I know it's going to be, it's in quadrant CAST 2 and no 1 CAST 3. So what are the 2 angles? If you want to use your drawings, you can, to figure out, what makes a opposite over adjacent equal to 1? 1, make it bigger. If I have quadrant 1, tangent is opposite over adjacent. What angle makes that into a 1? And in quadrant 3, the same thing. It would be opposite over adjacent. What angle creates these triangles? You can go about it, solve it that way. I don't like doing this. I always think about it as quadrant 1. If I have an angle in quadrant 1, what would the related angle be? And I like to do it from there. Okay, but it's totally up to you. What would you like to do? Use related angle or just use these triangles this time around? Do you care? No? I'll do it my way. Okay. I say, if it's in quadrant 1, if quadrant 1, tangent of 2 theta would be positive 1, and 2 theta would be pi over 4.
Theta's pi over 4.
2 theta is pi over 4. Whatever that angle is, it gave tangent equal 1. What if I did this? What if I substituted? I don't want you to be confused because there's a 2 in there. What if I said, if tan x equals to 1, what is x equal to? Pi over 4, right? It just so happens, instead of x, I have 2 theta. But who cares what 2 theta is? Tangent of it equals 1. So that angle inside it must be pi over 4. Okay? If in quadrant 3, then what is my angle? X would be quadrant 3, so pi plus the related angle. It would be pi plus pi over 4. In the same way, I have 2 theta is equal to pi plus the related angle. It is pi plus pi over 4.
Thank you.
And of course, because this question is a general solution, it doesn't give you a domain. What does that mean? This angle, 2 pi, is pi over 4 plus multiples of 2 pi. 2 pi is 5 pi over 4 plus multiples of 2 pi n. Of course, n belongs to real number, integers. Well, wouldn't that be nice? But when you solve something, we're more interested in just theta. So how do I get the theta all alone? Or I could talk about it as transformations. What does a 2 in front of the angle represent? No, transformation-wise. What does a 2 inside the tangent represent? What does 2 inside the function represent? In this case, it is a compression. So it used to be a cycle of 2 pi. But if I take my function and I compress it, what is my period now? 1 pi. Does that reflect 1 pi? No, I still have the repeat, a full cycle as 2 pi. But here's the magic of it. After you solve all the angles, if you divide everything by 2 to get the angle all alone, pi over 4 becomes pi over 8. And I repeat with the appropriate cycle. I'm repeating every pi because that makes sense. I have transformed it, and 1 cycle is half of what it was before. Same thing here. If I divide by a 2, this becomes 5 pi over 8 plus pi n. And so, yes, I reach my angle faster, I reach my angle faster, and I repeat my cycle every pi. So a question like this that involves 2 theta might be something slightly foreign to you. Luckily, we'll have more opportunity to look at questions like this. Don't fret too much. My focus or my hope is that you are able to handle questions like example 1 and 2 from your homework textbook. Do as many of these as your time can let you. For the rest of class today, I would like you to continue working on your assignment, whatever that might look like. If you have any questions regarding this, that's fine too. Come see me. We will continue example 4 and on tomorrow. Yes, you may. I will turn off the video.